Hello, I'm Dr. Nicholas Dogris, and today I'm going to run you through a tutorial of NeuroField EEG. As you can see, I have it installed on my computer here, so I'm going to just double-click and start the program. This tutorial reflects version 1.1.7.8 of the NeuroField EEG. When it starts up, what you're going to see is the CAN bus optimization screen and initialization. And so what it does here is it's looking for devices that are actually connected and powered up to the computer. So as you can see here, Q21 and the QCheck modules are found. When they are available, they will be displayed. If they're not powered up, then you won't see anything on the screen, and you'll see empty boxes like you see in the rest of the screen here. So to proceed with those connected devices, simply click on USB number 1. If you want to search for devices, you click on the magnifying glass. And if you want to bypass the initialization screen and do some artifacting and data analysis without any devices connected to the computer, simply click on the bypass screen. So we click on USB number 1, and it brings us into the program. Now at this point, you can see a couple subject names. You see last name, first name, and of course my name here. To enter a new subject into the database, you want to click on last name and enter the last name, and then you can tab down to the next field there and enter a first name, and then you can choose a gender, you can choose handedness, ethnicity, right, and then date of birth. So I'm going to enter 1/1/2000. Now this information hasn't been entered in yet until you click on the plus button. You'll notice it says add new patient. So I'm going to click on that, and now the patient has been successfully added. If you mouse over any of these buttons, it's going to give you a tooltip telling you what it does. Now on the left side here, you can see the patient that we just entered. To select that patient, simply put your mouse to the left of that patient last name, click it so it highlights the whole row. Then you're going to see the information here about the patient. Now at this point you have some options, but before we move on, I want to explain what some of these other buttons do. So this check button here selects the current patient that you have selected and moves you either into analysis or recording. This button with the circular arrows updates any patient info. So if I put the wrong date of birth here and I wanted to change it, I simply click into birth date and change it. Let's say it's 2001. And to update this, just click on the circular button, and now it's going to be updated. If I reselect the patient, then you'll see the reflected changes. Now, if I want to delete a patient, then I simply click on the minus button, and it will delete the selected patient. If I want to network the patient database, I click on this button right here, and there's instructions for taking the patient database and putting it on a shared drive on your network, and then pointing all of the NeuroField EEGs that you have installed in various computers to the same patient database. In this way, you have a synchronized patient database that reflects everything that's happening in your facility. For more information about that, please see the manual. On the left-hand side here, you see some toolbar buttons. On the very top, if you click on this one, this brings up this patient subject screen. The next button will bring up QCheck, our impedance meter. The next button will open a manual. The one after that will open the EEG recording screen. The one below that will open the EEG analysis screen. And the last two buttons are going to save or restore your patient database. If you're ever going to update this program, make sure that you back up your patient database. Simply click on this button here. It will back it up, and you're good to go. When you install the new version, it will automatically see the backed up database and then make it active. So that's a great way to make sure you save your data. All right, now we're going to move forward here, and I'm going to select me as a patient. And once I'm selected here, I'm going to click on the little check button, and it's going to open up this little window. It's going to say, well, do you want to make a new recording? Yes or no? Yes is going to take us to the recording screen. No will take us to the analysis screen. Well, I want to make a new recording, so I'm going to click on yes. So it takes us to our recording screen. And this is really simple to use. All you have to do here is enter the amount of time that you want to make your recording in minutes, and then click on the bullseye here to start the recording. Pretty simple. Most recordings are 10 minutes eyes open and 10 minutes eyes closed. You should get a good 10-minute record. That's the standard in the United States. And it's also necessary in order to use the independent components analysis portion of this program, which is machine learning. And machine learning takes a good 10 minutes of data in order for it to learn 19 channels. So just keep that in mind. Now, before you go recording any data, you need to make sure that your cap is attached to the person appropriately and you have very low resistances. So to do that, you want to use our QCheck impedance meter. Now, right here, you can see there's a button that says QCheck. I'm going to click on that and it will open up the impedance meter device. And what you do is you take your cap and you plug it into the impedance meter. Then you should take gel and gel up every one of the electrode sites and then attach your reference electrodes to the ears. Once you have everything gelled up and attached, then you should start QCheck. So I start QCheck now, and what you see are these crazy high impedance values. Well, it's because there's nothing connected to QCheck right now. But if you had a person connected, then you would see various numbers appear here. You can see that the numbers are changing every second. QCheck queries all the electrode sites every second. It will give you kind of a live idea of what the brain is doing in real time. Also, you'll notice that there's a ground and a reference site here. These are the two that you should start with. Make sure your references are connected correctly, and then your ground is connected correctly. And then you'll see the rest of the sites light up accordingly. Now, resistance is a key feature in getting good EEG data. And you want a resistance value less than 15 kiloohms, ideally less than 10 kiloohms, and for research purposes, less than 5 kiloohms. The other option here is a contact voltage. Now, contact voltages are another way to look at conductivity of the cap, but it also kind of tells you whether or not you may have a bad electrode or a broken wire or a wire that's starting to break. So if you click on the contact voltage here, you're going to see everything change, and these numbers are going to get much bigger. Now, if you see a contact voltage on a cap that's well connected and it's above 500, then you may have a broken cap. So this is a way to kind of check the integrity of the cap. Now, right now, I don't have anything plugged into QCheck, so it's showing you all the channels are impacted. All right, so if I uncheck this, this will bring us back to the kiloohms resistance. Now, the last thing you should know about this widget is you can actually change these numbers and make it respond differently. So if I want to, I can make the values different for red and for green and for yellow. And that kind of helps you to kind of narrow down if you're getting close to the number that you're looking for when you're setting a person up. So if I change my resistance value to 800 here, nothing's going to happen. But if I change my resistance number to 900, then what should happen is that everything turns yellow. All right, so you can change the actual color coding here. It makes it a little bit easier to set up your cap. Now, once it's all set up here, the next thing you're going to do is stop QCheck. So click on Stop QCheck, and it pops open this little guy right here. And it says, please turn off QCheck when you're finished. And we give you this little prompt because QCheck runs on a 9-volt battery. If you leave it on overnight, then that battery will be dead by the next day. So make sure you shut it off. And then the very next thing you should do is unplug the cap from QCheck and plug it into your EEG amplifier immediately. All right, some people make the mistake of leaving the cap plugged in the QCheck and then doing a recording and then finding that their data is not data but room noise. So click OK, and then now I'm going to shut off QCheck. And I just shut it off, and I'm going to close this portion of the program, which brings us back to the recording window. Now, to change the amount of time that you're going to record, simply click into this box that says allocate time and enter the number you want. So if I want to do 10 minutes like that, I would just simply have a 1 and a 0 there for 10 and then click on the bullseye. I'm going to do a 1-minute recording here. And I'm going to click on this and click on this bullseye here, and it opens up this window. Now you can enter information here, or you can just leave it all blank and just accept the defaults. It's up to you. You can put a diagnosis in here. I'm going to say none. Recording type, I'm going to say pre-treatment. And then I'm going to put my eyes condition, eyes open. Now for a clinician, you can put your name or somebody else's name, and then of course your technician name. I like to have this filled out so I know who did the recording. If I have any questions, I can always come back to them. The default setting for NeuroField EEG is to store the raw data. The Q21 and Q20 EEG amplifiers are DC coupled low noise amplifiers that are manufactured by NeuroField Incorporated. These amplifiers are the state of the art in recording, analog to digital recording. There's no multi-duplex switching. There's straight 19 pipes of data that goes straight into the converter and straight into the computer, which means that there's no slew in the recording quality. All 19 channels are being recorded simultaneously. And that's really great because, of course, we want to capture the brain and all these sites simultaneously. The other thing that's really cool about NeuroField EEG is when we store the raw data, we're storing a DC signal, which means we're getting everything that the amp can put out. The amplifier is a 256 samples per second amplifier, which means that it can record EEG data from 0 to 128 hertz. So by having this button checked right here, we're telling the computer, go ahead and grab that entire frequency range, real wide band. All right. So I'm going to do that. If you don't want to do that, you want to use a filter range, you simply uncheck this box and you can set filter ranges any way you want to here. You can also set up a notch filter. Now, it's really good to set up the notch filter post-recording. You can always take out that bad data later. All right, so I'm going to leave it like this and click on this button that says Set Recording and Start. Now it's going to start recording here, and what you see is a bunch of room noise because I don't have anything plugged into the amplifier. So at the bottom here, you can see the recording time. It's the elapsed time and the little progress meter here. As it goes through the recording, of course, you want to give the person the instructions to keep their jaw relaxed, forehead relaxed, keep their eyes fixed on a specific target in the room. I usually designate a target in the room that is going to make them look down a little bit instead of looking up to avoid frontalis muscle artifact. I usually record my EEGs with eyes open first and eyes closed second. And it's up to you in terms of which order you choose. So the way the system works, you can pause the recording at any time. You can stop the recording at any time. But once you hit the amount of time that you put in here, the system will stop automatically, and then it'll ask you, do you want to save your data? Save your data. Click OK, and it's going to open up a screen here, and it's going to say, okay, I want to save the data in the patient ID folder. And you can see the path here. C drive, NeuroField EEG, NeuroField data, patient data, and PID2 data. So we label every patient that you enter into the subject database gets an ID number assigned to them, and then it will create a folder where the data is saved. So we will give you a name. We'll actually create a name for your data, or you can name it anything you want, and you can save it anywhere you want. So these are just kind of default values. I'm going to save this and let it stop at this point. So now we're done with our recording, which is great. And what we want to do is move into analysis. To move into analysis, simply click on EEG Analysis button. Okay, so we're in the recording, the analysis screen now. So to analyze the data that you just recorded, simply look at these buttons here on the left side. One of them is a little folder with an arrow. And what this guy does is it opens your data. So I'm going to click on that. And it takes you to the patient ID folder. Now here's the recording that we just made here. I'm going to load that in just so you can see what noise looks like. And there's room noise right here. You can see 100 microvolt level here, really noisy. And you should get to know what all the morphology of EEG looks like. And this is part of the training that we offer. But this is the room noise that you just recorded. And you can see how cleaned up it is now. It's because a filter was applied to it and a notch filter was applied to the data. So you can actually see what white noise looks like. But we want to see what a real EEG looks like. So what I'm going to do here is I'm going to click on the open button again. And I have a couple of pre-recorded files here. I'm going to open this EO1, which is an eyes open recording. And we're going to load that. Okay, so now you can see it loaded flatlined, and the value was 500. Sometimes it'll do that because the scale, the swing of the amplifier will actually make it scale out to a big number. So use your mouse wheel to zoom in or zoom out. All right, you can change the zoom at any time. So I'm going to bring it down to 50 microvolts, which is pretty much normal in EEG. And now you can get an idea of what all these 19 channels look like. There's a lot of features in this analysis window that are really cool, and you should get to learn how to use. Of course, we do go over this in training. But if you grab the scroll bar, you can scroll through your data and see what happened all the way through. It's loaded in the linked years montage. You can change montages simply by clicking on montage and change it. I'm going to change it to average reference here. And now we're in the average reference montage. We also have Laplacian and log bipolar as well. So this is one really cool option to change your montages to get a better view of the data and different views of the data. Another cool feature is you can look at field and phase by simply highlighting a tracing. And when you put your mouse over it, it'll turn a different color. Click on it one time. And on the right side, you're going to see this little window open up, and you can grab it. And you can move a trace over another trace. This allows you to check field and phase against other electrode sites, which is kind of cool. You can actually choose multiple lines at the same time if you want to do more than one kind of comparison, which again is a cool feature. To select data, what you want to do is on the open area above the data, this little white area, you want to double click one time. If you double click, it'll lay down a selection for 1 second. Now, this is a window that moves. If I put my mouse in the middle, you can see how the cursor changes to right or left. I can move it this way. If I go to the end of the selection, it changes the cursor again. I can stretch it and make it longer for a longer selection or a shorter selection. Okay? So that's how you select data. If you want to delete this, you right click on it and it goes away. If you want to make longer selections, then you'll notice here on the right hand side it says new length. The default is 1 second. If I change it to 3 and then double click, it automatically grabs 3 seconds of data. So it's up to you in terms of how much you want to grab. If you want to grab the whole record, so I'm going to go over here and I'm going to grab this whole record. I'm going to say, okay, I want to grab, it's a 10-minute record. I'm going to say 600 seconds. And I'm going to double click on it. And now what it did was it grabbed everything that was there. And if I go to the edited tab, you'll see the entire record is saved there. And it's over here on this side. So I grabbed it all. Now for independent components analysis, you do want to do that. You want to grab the whole record. And once you grab it, then you want to save it as an XDF file. So you'll see one of the buttons that says XDF. These are file formats that you can save in. And I'm going to click on that, store data to XDF file. And I'm going to store it. Now it brings me back to my patient folder. And I'm going to click on new folder. And I'm going to call this EO1 XDF. And I'm going to enter into here. And I'm going to call this one EO1 XDF and save it. Now that big old file that I just selected is saved as an XDF data file. And you'll know why this is important in a little bit. I'm going to go back to my Open Artifact Recording tab here, and I'm going to right click and delete that big old chunk of data. And now we're back to square one where we started. So I'm going to change my length back to 1 second. Now in traditional EEG artifacting, you want to go through the process of selecting data. If I click in the field, my right and left arrow keys on my keyboard will become active. So I want to start grabbing some EEG data. Now you make your selections, you grab your data, and whoops, I just turned on my little screen here. And grab your data and then pull it to grab a chunk of data. Now in the EEG world, you want to grab a good 60 seconds of artifact-free data. I have a couple rules for doing that. Whenever you're examining data, you start from the top and you look at FP1 and FP2. The first question you ask, is there an eye blink, yes or no? Then you look at F7 and F8 and you look for lateral eye movement. And you say, is there lateral eye movement, yes or no? And then you look at T3, T4, and look for jaw or muscle. And you also look at FP1 and FP2 and look for jaw or muscle artifact. And if it's negligible and low, then you can say, well, this is acceptable. If it's not, then you omit the piece of data. So I go through those pieces of decision making when I'm selecting data. There's far more to learn about morphology and how you actually do this, but that's a good way to start. Once you select a piece of data, then you can grab as much as is going to be needed. Now over on the upper side here, you can see the edit time is at 20.86 seconds. And I'm going to take it all the way up here and get to 1 minute. You want 1 minute of good data. All right, so once you have 1 minute, I'm just going to grab data here. I'm going to avoid the eye blink. I'm going to avoid this big chunk of muscle. You want to get as clean data as possible when you do your standard selection of EEG data. Again, I'm not being particular here, and I'm not selecting particularly good data. I'm just filling in my 60-second gap here. So we're at 58 seconds, 59, and I pull it all the way to 63.83. Now, once I have my data, I go to the edited data, and I'm going to save it. So I click on SAV button here, and it says store data to edited file. Yep, I want to store it, and so it brings me back to my patient data, and I'm going to call it EO1 edit, and save it. Now at this point, I have a couple choices. I can look at my data in Loretta and source my surface data into a three-dimensional sourcing algorithm. And that's the button that says LoreB. Click on that, it stores data and launches the Loretta viewer. Now it wants to save it. I'm going to call it EO1 Lore and save it. It'll take the data, crunch it, and munch it, and put it into the Loretta viewer. It'll also create a Loretta file that later on you can come back and look at, and if you want to reopen the viewer. And this gives you the ability to look at the Loretta data from 1 to 70 hertz. There's a lot to learn about the viewer and different things that it shows you, but this is a great way to source surface data. Now, once the surface data is sourced, then you can do a power analysis. From here, you want to make sure you select the correct eye condition, open or close. Well, we're looking at an eyes open EEG, so we're going to leave it on open. It's one of the mistakes people make sometimes. There's a difference in the data, obviously, and you want to make sure you match the eye condition to the eye status. Now, when you're ready to go, simply click on PWR, and it's going to open up a power analysis. And it's going to create a whole bunch of different metrics for you. Absolute power, relative power, power ratio, spectra, and tabular data. It's also going to create an estimated z-score data, which is estimated z-scores based on the literature. It's going to create spectral plots for you as well. All this information is really, really relevant, and it can be condensed down into an individual report. So there's a lot here. You can see your brain map, the band maps, z-score data, single hertz data, relative power data, power ratio data, spectra data for every one of the sites, along with the peaks. You can turn cursors on and move the cursors back and forth to pick out specific areas here. The first number is the frequency. The second number is the microvolt level or amplitude. Both of these cursors can be moved and set. This data will actually be put in the report. The green tab allows you to look at the actual numbers. So this is the tabular data. Cool thing about NeuroField is that you can actually go to baseline data setup, click on make baseline. It says copy all analysis to montage to baseline, say yes. Now what it's going to do, it's going to take this EEG and it's going to make it the baseline for this particular patient. So now it's set up. If you do treatment and then do another EEG, you can come back, analyze the next set of data, choose change from baseline, run another analysis by clicking on the status button, and it'll show you the percentage difference from the first EEG to the second EEG. If you go back to the head map tab and the head map control tab, over here you can change the amount of baseline percentage that it displays. So it'll do plus or minus 15% changes in the EEG, or you can change it to a 50 or 100. The other thing that's really cool is that you can make a report. Click on PWR and it will actually open up this window and say, okay, I want to do a power analysis report. Select that button. It's going to say, hey, I see, do you want me to use these new settings? Say yep. And now what it's going to do is create a power analysis based on the change from baseline. And then what it will do is actually calculate a report for you, which is kind of cool. The program has been made to be as simple as possible, but with a lot of depth, so that you can do a wide variety of recordings, essentially. Okay, so now it's all done, and the report was done. It shows you down here that the report was placed in the patient ID folder. So if I navigate to that folder, then you see your baseline report is there. All right, it's a Word document. It's going to, you can make your own logo and cover page. You can modify the text that goes into the report. There's a number of ways of doing that. And then you can actually see the tables here. It'll put them all together with all the data that you collected. And it's kind of cool, spectra, the whole nine. So a nice professional report. If you want to change the actual text that goes in the report, you go to NeuroField Data, Test Data, Report Text, and these files can be changed. And whatever you put in the cover page or Loretta info or QEEG intro, that data will automatically be used when the report is generated. Alrighty. So much functionality, so cool. All right, so now another thing you can do is you can run independent components analysis, which is a cutting edge form of computational neuroscience. We utilize the system that was created at UC San Diego, and it's EEG Lab. So we're calling EEG Lab and asking EEG Lab to conduct a independent components analysis of the data. Now, in order to do this, you have to make sure you have done that first step that I outlined at the beginning of this tutorial, and that is to make sure that you save the entire data set as an XDF file. So all you have to do is click on ICA, and then it's going to say, okay, give me my XDF file. So remember, we put it in this folder, and there it is. And I'm going to click on Open. And then it's going to load that data, and it's going to start the ICA process. The first thing it's going to do is it's going to open a EEG lab, and then it's going, you have to do 2 steps in order to start the independent components. So we're waiting for it to start up here. It only takes about, it could take anywhere from 30 to 60 seconds depending on your computer. Here it's starting here. And now this first step is channel rejection. If you have a bad channel, then you want to write down whatever channels that are bad and then click on cancel in the lower left-hand corner. Then if you enter them here into this window with a space in between each one. All right. Now if all the channels are good, just click on cancel. And now the next thing it's going to do is it wants to get rid of bad data in your recording. Now you can do that if you want to. And if you want to get rid of this bad data, click on the reject button. If you want to omit this step, click on the cancel button. If you want to keep a piece of data, simply left click on it and it will go away. To select a piece of data, click and drag and it will select that piece. So I'm going to reject this. And then it wants you to name it. Of course, you can name the data set if you want, or if you want us to name it for you, just click OK. And now AMICA is running, which is the Adaptive Mixture Independent Components Analysis. This procedure can take anywhere up to 15 to 20 minutes, depending on your computer, speed, memory, all that kind of stuff. So I'm going to pause for a moment until we get to the next step. Okay, now AMICA is finished here. And after it's done, there's a number of steps that happen. We're going to take that data and convert them into Loretta files. We're going to do what's called dipole fittings and source the components into a three-dimensional space. And then we're going to run it through another plugin in EEG Lab called IC Label, which is a categorization program that allows you to take the components that are generated from the AMICA analysis and compare them to databases that have different artifacts like eye movement, brain, muscle, heart. It's a great program. The references for AMICA, EEG Lab, IC Label are all in the manual. So now what it's doing now is it's generating all the ICs for you, and it's showing you which ones are which, where they're located, and it's saving each one of these into a folder called figures so that you can go back and take a look at it. The cool thing about independent components analysis is it can target a specific type of artifact, and then it can allow you to do what's called data cleaning. So now it's done and saying, okay, in the next window, it wants to get rid of some components. So I'm going to click OK. Now this is the list of components it wants to keep. Okay, so if I go to my folder where I put my initial file, that XDF file, and I click into here, now you see all this data. Now this .set files are what's used in MATLAB, and you can get into more advanced post-processing of the data if you want to. But in here, in the figures folder, these are all the IC labels that were created. And you should go through them one at a time to determine which ones you want to keep. And it wants to get rid of 1 and 2. And so, for instance, if I look at number 1, this is 79.4% match to other. And you can see here, this is what an artifact looks like. So you wouldn't want to keep this one. And so it's kicking it out, rightly so. Then the second one, 99.5% match for eye movement and eye blink. And you can see where the location of the dipole is in here. Number 3, it wants to keep. And you can see where this IC is located and the spectra associated with it, which is really cool. It's a great, great form of analysis. Again, this is advanced and something that you learn in training. So you would go through an entire process of selecting and rejecting ICs. Also, what's saved is all the ICs are converted into Loretta files. So if you want to, you can actually view an IC in the Loretta viewer and look at that component specifically, which again is invaluable data. Once you're done here, you just click OK, and it'll say ICA analysis complete. And now it creates a file called cleaned. And so if I go back over here to my EEG data, you can see this is the original data set that we had created. And I'm going to go to Open, and I'm going to go into the folder where we created that. There's the original XDF, and below it is one. Now there's a little piece attached to that file called clean. The data is cleaned. I'm going to click on Open, and now this is what you see after the components are actually removed. So if we scroll in here, you can see how the eye blinks have been removed from the data. It actually reveals more neural data, and it's corrected essentially from the artifacts that it contained initially, which is again invaluable when you're working with a data set that could be really challenging. From this point, if you want to, you can click on Power and actually run another power analysis on the clean data. Just keep in mind that this data is now in average reference and that your power analysis is not going to be linked years. It will reflect an average reference montage. Okay, so this is a brief tutorial of the EEG program. I know I hit you with a lot of information. There's a big universe awaiting you here in the EEG field. And when we analyze the most complex noise in the known universe, it's really exciting, but it's also daunting at the same time. There's a lot to learn. We offer training courses and consultation to help you along the way. I hope this was helpful. Have a great day.